React hooks. Hooks lets us use different features from our components. There are many built-in hooks in React. They can also be combined to create a new hook. Let's see all the built-in hooks. Use state hook. It lets a component remember information like user input. We can use the use state hook to declare a state variable that we can update directly. The parameter we pass to the use state hook is the initial state. It can be of any type. This argument is ignored after the initial render. We can also pass a pure function, which is a initializer function which takes no argument to the use state hook. The initializer function is called by the React while initializing the component and stores its return value as initial state. Use state returns array with two values. The first value is the current state. During the initial render, it will match the initial state we have passed. This value is considered read only and it should be updated through the set function. The set function that lets us update the state to a different value triggers a re-render. The argument to this set function can be a value of any type or a function that takes the pending state value and produces the next state value. If we try to access the state variable immediately after calling the set function, we will still get the old value because the new state value is reflected only in the next render. If the new value is equal to the old value according to the comparison provided by object.is method, then React skips re-renders. If we update multiple state variables in a single event, React re-renders the component only after all the set functions are executed as a performance optimization. The convention is to name the state variable like value, comma, set value using array destructuring. For example, here we use the useState hook to create a count variable and count state update function. Calling a set function of type setValue of value plus 1 multiple times in the same render function has the same effect of calling it once. For example, here setCount of count plus 1 is called 3 times, but every time the button is clicked, the value is incremented by 1. We can replace the setCount of count plus 1 with setCount of a function that takes a previous count and returns the updated value. That is, we are passing an updated function instead of value. Now, when we click the button, the value is incremented by 3. We can put objects and arrays in a state variable. For example, here we are using a form object which contains first name and last name properties. While updating the state, we replace the entire object instead of mutating the object. Even when we update the nested object, we need to copy the nested object which we are updating as well as any object containing it on the way upwards. For example, here the article object's name property is updated in the event handler. Arrays can be used in state variables. Like objects, the array should not be mutated. Instead, we need to replace the array. For example, here a new array is created on every add to do operation. We can also pass the initialization function to use state as shown. Here we are only passing function references instead of executing the function and passing its return values because in that case the function is executed for every render. We can reset the state of the child component tree by changing the key prop as shown. Here when the reset button is clicked, it updates the version and the updated version is sent to the key prop of the form component. We can save the previous state in a component by creating a state from input props. Here, priv count refers to the last set count. We can compare priv count with count to determine whether count is increasing or decreasing. However, this pattern should be avoided since components should be pure. That is, rendering of a component should not depend on previous render of it. When we need to store the function in a state, we should not pass the function reference directly as shown in the code's input because React considers it as an initializer function. Instead, we need to pass the initializer function that will return the required function reference. Use reducer hook. It lets us add a reducer to our component, which is used for managing state. The reducer function specifies how the state gets updated. It must be pure and take state and action as arguments and should return the next state. The state and action can be of any type. The second argument to use reducer is initial arg is the value from initial state is calculated. How the initial state is calculated from initial arg depends on the third argument init. If init is not provided, then initial arg is the initial value. Use reducer returns an array with exactly two values. First value is the current state, that is the calculated initial state. Second is the dispatch function that lets us update the state to a different value and trigger re-render. We need to pass an action to the dispatch function. React will set the next state to the result of calling the reducer function with the current state and the action that we pass to the dispatch function. The action can be of any type. By convention, action will be an object with type property and some additional properties. Like the set function that is returned from useState function, dispatch function will update the state only for the next state. React will skip re-rendering if the new state is the same as the old state by object.is comparison. For example, here we are storing the year value in the state object initialized with value 2025. We pass the reducer method and this initial state object to use reducer hook. It returns the initial state and dispatch function in the button click event handler. We call dispatch method with action object. React passes current state and action to the reducer method. The value returned by the reducer method is the next state. The use reducer is very similar to use state, but it lets us move the state logic to a separate method other than handling in the event handler. The reducer method should not mutate and return the same state object. Instead, it should always return a new object. Use context hook. It lets a component receive information from distant parents without passing it as props. For example, an app's top level component can pass the current UI theme to all components below. Here, theme context is created using the create context method and it is included in the app component. Its value is set to the theme object. The context itself does not hold the information and it only represents the kind of information that we can provide or read from the component. Level 2 component accesses the theme object using use context hook. Use context returns the context value. It is determined as the value passed to the closest theme context dot provider above the calling component in the tree. If there is no such provider, then the returned value is the default value we have passed to the create context method. React re-renders all the children components that read some context starting from the provider that receives a different value. If we need to change the value passed in the context provider, we can create that value as a state using useState as shown here. We can override the value for the context provider for a part of the tree, like shown here. Use ref hook. It lets a component hold some information that is not used for rendering. Updating a ref does not re-render the component. They are useful when we need to work with non-React systems such as built-in browser APIs. Use ref declares a ref. We can hold any value in it. Most often it is used to hold DOM nodes. Its declaration is use ref of initial value. UseRef returns an object with single property current and its value is set to the initial value. We can change the value of this property. If we pass the ref object to ref attribute in JSX node, React will set its current property to DOM node. On the next render, useRef returns the same object. Since ref.current is mutable, we should not store any state that is used for rendering in the ref object and we should not read ref.current while rendering. We should not create the ref object for every render. React saves the initial value once and it ignores it on the next render. For example, the expensive object creation method is called on every render but its return value is used only in the initial render. Instead, we can initialize the ref object only when its current property is null. The condition will be true only for the initial render or if we manually update its value as null. Let's see an example usage of useRef hook. Here we have two buttons start and stop which will call start timer and stop timer respectively on its click event handler. The start timer method will call the set interval method with a function which is used to update the second state. The interval ID received during the set interval call is stored in the interval ref.current property. In the stop timer method, if the interval ID is set in interval ref.current property, it is passed to clear interval method. Using ref objects, we can store information across re-renders unlike regular variables which will reset on every render and we do not want to risk storing information of a component in global variables. The information in the ref object is local to each copy of our component. Let's see another example where useRef is used to get the DOM object of an element. Here, React creates the input DOM node, puts it on the screen, and it will set the current property of the input ref object to the DOM node. Now, we can access the DOM node. React will set the current property back to null when the node is removed. Another hook is use imperative handle that lets us customize the handle exposed as a ref. Here, my input ref is created in the app component and passed as a ref prop to my input component. Now, my input component uses use imperative handle to convert the ref object to a custom one. Now, the parent app component can use this customized ref. The parameters passed to the use imperative handle are the ref object and the create handle function that takes no argument and returns ref handle we want to expose, and the optional dependencies, the list of all reactive values that is referenced inside of the create handle method. The use imperative handle hook returns undefined. Use effect. It lets us synchronize with the external system. This includes dealing with browser DOM, animations, widgets written with different UI libraries. Here we are displaying the current time. The first argument to the use effect is the setup function and it can return a cleanup function. When the component is added to the DOM, React will run the setup function. The second argument is the list of dependencies. For every re-renders with the changed dependencies, React will first run the cleanup function if provided with old values and then it runs the setup function with new value. After the component is removed from the DOM, React will run the cleanup function. Here we are not using set interval, instead we are using set timeout function. Once the date state value is updated, React will re-render the component, and since the setup function provided date state as its dependency, React will run cleanup function and then it runs the setup function again. Using set interval with an empty list of dependencies is better for these scenarios. The dependency includes prop, state and all variables and functions declared inside the component. The second argument to use effect is optional. If it is not provided, React will rerun the setup function for every rerender of the component. Use effect return undefined. Every reactive value used inside use effect must be specified as a dependency. Effects with empty dependency do not rerun when any of the component prop or state changes. We must avoid using component local variables as a dependency because local variables differ for every render. Instead, we can declare those variables inside the effect function. Effects are escape hatch. You can use them when you need to step outside React and there is no better built-in solution. If the effect logic is repeated in many components, we can extract that logic and create it as a custom hook. Here, use chat room hook uses use effect hook to connect to a server URL. The setup function depends on server URL and room ID. So, whenever any one property changes, the cleanup function is called, which disconnects the existing connection and connects again using new server URL. Then this hook can be used in any component. We can use effect to fetch data for the component. Here, once the component is loaded, we fetch the employee details for the default employee alias. If the employee is updated, then the setup function will be executed again. Use layout effect. It is the version of use effect that fires before the browser repaints the screen. The code inside use layout effect setup function and all setup functions scheduled from it blocks the browser from repainting the screen. Use insertion effect. It is the version of use effect that allows inserting elements into the DOM before any layout effect fires. As it runs the setup function before the layout event, we can use this function to include dynamic CSS. This will optimize the performance since browser has to recalculate the layout of all the affected added DOM elements if we include dynamic CSS later. Use memo. It lets a component to cast the result of a calculation between re-renders, skipping expensive calculations. The first parameter to use memo is the calculation function, calculating the result that we want to cache. This function should be pure and takes no argument. It can return a value of any type. During re-render, only if its dependencies are changed, the passed function is executed, otherwise the cached value will be returned. The second parameter is the list of all reactive values inside the calculation function. We can make React skip the re-rendering of a component by passing the component function to the memo function. If the props sent to the component matches the previous props using object.is comparison, then the component is not re-rendered. Use callback. Use callback is very similar to use memo. In use memo, we send a calculation function which returns a memoizable value, whereas in use callback, we pass a memoizable function as an argument. Here, we use callback to cast the filter to-dos function. We pass this function as a prop to to-do list component. If the to-do list component is expensive to build, we want to avoid re-render of this component if data is not changed. If filter to-do is defined as a normal function, then it will be a different function definition whenever the app component is re-rendered. Then it will re-render to-do list component also. By using this pattern, that is using a callback or use memo with memo of component, we can make React skip re-rendering of a component. Use transition. It lets us render a part of the UI in the background. It returns an array with exactly two items. The first element is pending flag that indicates whether there is a pending transition. The second element start transition is a function that helps to mark updates as transition. The function passed to start transition is an action that updates one or more states by calling the set functions. React calls the action function immediately with no parameter and marks all state updates scheduled synchronously as transitions. Any async calls that are awaited in the action will be included in the transition but require wrapping any set function after await in an additional start transition function. State updates marked as transitions are non-blocking. The state updates performed inside an async function will not be marked as transition. Here, the use transition is used for updating the total cart value. Instead of showing the updated total value for every cart item edit actions, we update the total value in a start transition function. First, we make an API call which is an async code. After fetching the result from the API call, we update the total state in a separate start transition function. The is pending variable will be set to true when we make a call to the first start transition function, and the is pending variable is set to false when all the state updates which are scheduled by start transition are done. When we perform the same operation without the start transition function, and when the user performs more than one cart edit actions faster than the API call execution, say a user increases the quantity of a cart item in quick succession, which is done faster than the API execution of one quantity increase, then we will make three API calls and we will update the total value for each API call response. Instead, when we use transition, is pending flag is cleared only when the transition completes and we will see only the final value. When each API request takes a different time to respond, that is, if the previous request takes more time the later request, then component will be in the wrong state because updates are scheduled asynchronously. The actions within a transition does not guarantee execution order. Use deferred value. It lets us defer updates to the part of the UI. Use deferred value accepts two parameters. The first parameter is the value that we want to defer. The second parameter is the initial value. If this parameter is not provided, then the initial render is not deferred because there is no previous value. It returns the current value. During the initial render, this value is same as the initial value or same as the value provided. During updates, React will first re-render with old value, so it will return old value and then try another re-render in the background with a new value, so it will return an updated value. This background re-render is interruptible. If there is another update to the value, React will restart the background re-render from scratch. The background re-render caused by use deferred value does not fire effects until it is committed to the screen. Here we have a state variable query and a deferred value deferred query. We pass deferred query to the search results component. It takes around 200 milliseconds to load search results component. The search results component is memoized using memo function. This is done because every time we update the query state variable, the app component will be re-rendered. So its child component search results will also be re-rendered. As a user types a character in the input field, it is updated immediately in the query state variable, but in deferred query variable, the new value is updated only after the search results component is ready to be shown with the new value. Also, this use deferred value is interruptible. So if a new value arrives while a component with old value is rendered in the background process is cancelled and the render is restarted with the new value. The deferred value is different from debounce time and throttle functions because in debounce time, we wait until user leaves a gap of some time, say 1 second while typing, and we run the operation. In throttle, we may limit the operation to perform at most one time in a second, but in deferred value, the operation is performed immediately if any new value is provided, meaning if there is a network call, we make a network call for every new value. Even if the deferred value is interruptible, the network call will be made and we may not process the response. Use sync external store. It lets us subscribe to the external store that is not handled by React. We pass three arguments to use sync external store. The first argument is the subscribe method, which should receive a callback function as an argument and it should return an unsubscribe method. If we pass different subscribe methods in different calls, then React resubscribes to the store. We should avoid declaring subscribe inside a component as it will be a different function definition whenever a component is re-rendered. We should declare subscribe method inside use callback hook while declaring inside component, or it is better to declare subscribe method outside the component as shown here. The second argument is the get snapshot function that returns the current snapshot of the external store. The get snapshot function should return the same value as compared by object.isComparison. When data in the external store is unchanged, as React will re-render the component whenever the get snapshot returns a new value. If getSnapshot always returns a new value, then React will re-render the component in an infinite loop. The third argument is required only for the server render. It will return the initial value, and also if the store is not available, this function returns the current snapshot value. Use sync external store returns the current snapshot value. Here we use sync external store to check whether the user is online or offline. We have an online and offline event listener. We have created a subscribe function that will subscribe to this event listeners, and our subscribe function returns an unsubscribe function that unsubscribes from this event listeners. We also have the get snapshot function that just returns the navigator.online value. We pass this subscribe and get snapshot function to use external store. Use debug value. It lets us add a debug value to a custom hook. We pass two arguments to use debug value hook. The first argument is the debug value that will be displayed in React DevTools. The second argument is the format function that will be called passing the debug value, and it should return the formatted value. Use debug value hook does not return any value. Here we use the same example to check whether the user is online or offline. Now we have introduced the custom hook use online status for it. Inside this custom hook we have used debug value. We can see this debug value in React DevTools. Use ID. It is used to generate a unique ID that can be assigned to the ID attribute of the element. Use ID does not take any argument. It returns a unique ID. Use ID cannot be used for generating keys for repeating items as it is used in the top level of the component. If we assign some static ID to an element in the component, we cannot include more than one component since the ID must be unique. In that case, we can use useID as it will generate a unique ID for each instance of the component. Here, useID is used to generate value for the ID attribute of the input element, and the same value is used in for attribute of the label element. We include the label and the input component two times. If we use more than one React application in a page, then we can pass identifier prefix as an option to create root function. This ensures that ID generated by two applications never clash because every ID generated by use ID will start with that distinct prefix that we have specified. Use action state. It allows us to update the state based on the result of a form. We pass three parameters to the use action state hook. First parameter is the action function, which receives two arguments, the previous form state and the current form state. First time when this action method is called, it is called with an initial value which is passed as the second parameter to this hook as the previous form state, and the current form state is sent as the second argument. The action function should return the next form state. This returned state value will be the first argument to the action function when it is called the next time. The second parameter is the initial state. First call to use action state returns this value. Subsequent calls to use action state returns value that is returned by the action function. Third parameter is a permalink, which is a string containing the unique page URL that this form modifies. It returns an array with three values. The first value is the current form state that is returned by the last execution of action function or initial value passed if the action function is not yet executed. The second value is form action handler that we must pass to action prop of form element or form action prop of button element inside any form. The third value is pending flag that indicates whether there is a pending transition. Here we have a form with one text input for name and number input for age. When the form is submitted, the form action will be called. In the action function, we check whether name is not empty and age is not negative. If the form data is not valid, then we set is success as false and send an appropriate error message. If the form data is valid, then we set is success as true and send a success message. Use optimistic. It optimistically updates the UI. Sometimes after we fire some async operation, we may need to show some progress to the user until the async operation completes. It takes two parameters. The first parameter is the state to be returned initially and whenever there is no action is pending. The second parameter is the update function that takes the current state and the optimistic value as the argument and returns the optimistic state. Use optimistic returns two values. The first value is the optimistic state. It is equal to state unless an action is pending, in which case it is equal to value returned by update function. Second value is add optimistic function. It is a dispatching function which takes one argument optimistic value and will call the update function with state and optimistic value. Here, thread component users use optimistic to show the new message with sending progress before being actually sent. In the app component, we have the messages state and send message handler. We pass the send message handler to the thread component. The thread component has the new message form. When the user types the new message and submits the form, then immediately we pass the new message to the add optimistic message function, which will show a new message with sending status. And then we call send message handler, which is received from parent app component. The send message calls the deliver message async operation. Once this async operation is completed, then it updates the messages state, rendering the app component and the thread component. Thanks. If you find this video valuable, you may share it with others. If there are mistakes, please mention them in the comment section.